So let's start at the beginning. You first need an ore body, and there we are. So as I mentioned before, we've got a JORC-compliant resource of 532 million tons. Technically, at 650 parts per million, at a cut-off grade of 200 parts per million of total rare earths less cerium. I think what it really means that for every 1 million kilograms of ore we process, we'll get 650 kilograms out. So it's minute quantities. So for every 1,000 tons we process, we'll get 650 kilograms out. That is a lot of ore that we have to move. It was discovered when the government flew radiometric airborne surveys back in 2011, and some of our very clever Ugandan partners discovered the anomaly, and the rest, as they say, is history. And we've gone from strength to strength. In order to establish whether the resource is there and what's under the ground, we have drilled, well, the entire Makuutu deposit has enjoyed 15,000 meters of drilling. That's 15 kilometers of drilling. And every single meter has been recorded and logged for things mentioned at the bottom, for moisture, color, rock type, veining. And knowing some of our geologists, they probably even marked what the rocks tasted like. But that's up to them. So you can see that a lot of work just to establish whether you have a resource body has gone into this. Just on the side there's an example of how we record the logs. There's about 9 meters of core, and every single meter has been documented. And we've got loads and loads and loads of trays just like that in storage. And after all that effort, you get to draw pretty graphs like this one. And this is a cross-section of our deposit, and you can get to see the various layers of clays within the clay. So we have a hard cap layer, we've got clay, we've got upper saprolite, lower saprolite, and then you've got the sort of fresh rock, as they call it, and we know it's siltstone, mudstone at the bottom. But there, all that effort, and you can see at each layer, each hole that was drilled to support this, what is strictly called a regolith graph. So there we know what's sitting there. We see we're facing north, and there's west and east on either side. And we can do that for virtually all of the ore body. So it's not enough just to have rocks as your ore body. You need to have the right type of rocks. And these are the further tests, geological and metallurgical, that the deposit has overgone. And I've just listed them down. So we've had 1,206 bulk density tests. We've tested 125 samples for multi-element whole rock analysis. We've done 32 samples for just mapping different types of clay. On the metallurgical side, we've sent samples off to universities for analysis and testing. We've done initial tests before we did the main test. We've done 600 bottle roll tests. And just to really impress upon you, I just want you to think about a bottle roll test. So what happens is we extract a sample, we send it to the lab for analysis. That sample is then prepared and analyzed. So you've got to describe what's going into the process. Then you mix it with a leaching agent or a lixiviant, as they refer to it. And then they shake it in a test tube or roll the bottle, hence the name. And then they've got to wait. Then the results of the test are recorded and documented. And that whole process is just one test. So if you imagine one person working 365 days of the year, 600 bottle roll tests will take that one individual a year and 8 months if he works weekends as well. So when you look at the amount of work in here, I want you, every time you see 600, I want you to add a day to it, just to get a sense of the amount of work that's gone into the metallurgical and geological analysis to establish the resource that we have publicized to the market. So, in summary, geology, which is the rocks and the layers, plus the grades, which is the amount available, plus the metallurgy, whether you can actually get access to the material that you want, equals your resource body. So far, so good. So now we've got a resource. Now we mine it. Now, with